Determine all critical numbers for the function f of x equals the square root of x squared minus 16 divided by x plus 2. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals the square root of x squared minus 16 divided by x plus 2. We can rewrite the square root as a fractional exponent. First power, second root, 1/2 power. And then over x plus 2. So the function has an even root. The denominator of a fractional exponent is the root. It's an even number. And the function also has a denominator. For the domain, what is inside of an even root has to stay greater than or equal to 0. So x squared minus 16 has to stay greater than or equal to 0. And what's in the denominator cannot equal 0. So x plus 2 cannot equal 0. Starting with the x squared minus 16, we can add 16 to both sides. We can now take the square root of both sides. The square root of x squared is the absolute value of x. The square root of 16 is 4. Here the absolute value is greater than or equal to 4. And so when we remove the absolute value symbols, this will put x greater than or equal to 4 or less than or equal to negative 4. It's outside of the 4 and the negative 4 instead of in between them. Working with the x plus 2, we can subtract 2 from both sides, and x does not equal negative 2. We have all three conditions needing to hold true for the domain. The x does not equal to negative 2 is not within either of the two intervals because negative 2 is not greater than or equal to 4, nor is it less than or equal to negative 4, and therefore it's not needed because it will not further affect the domain. So this alone will be the set of conditions needed to follow for the domain. So the domain will be everything less than or equal to negative 4. So it'll start at negative infinity, go up to negative 4, and include it, so square bracket on the negative 4, union, and it will be everything greater than or equal to positive 4. So it'll start up again as positive 4. It will include that, so square bracket, and go to positive infinity. The next thing to do is find the derivative. We have a quotient here, so we will make use of the quotient rule. Derivative of the numerator, its power rule. Bring down the power, leave the inside alone. Subtract 1 from it, I will call that 2/2. Multiply by the derivative of the inside to complete the chain rule. And then times the denominator left alone, minus the numerator left alone times the derivative of the denominator, which is a 1. And the entire thing over the denominator squared. The first term in the numerator, the 1/2 and the 2 can multiply each other, which will become 2/2 or 1. There's also an x and an x plus 2 that can move to the front. And there's an x squared minus 16 to the 1 minus 2 negative 1/2 power minus second term is 1 times x squared minus 16 to the 1/2 power. 1 times anything is itself. All of this is over the denominator, which we will leave alone. The first term in the numerator does have a negative power for one of the expressions, so we can move to the denominator to become a positive power. The x and the x plus 2 will stay in the numerator. And the x squared minus 16 to the negative 1/2 will move to the denominator to become positive 1/2. We'll leave the overall denominator alone. Since we have a fraction for one of the terms in the numerator, we will want to get a common denominator with the other term in the numerator. So the other term in the numerator can now be multiplied by x squared minus 16 to the 1/2 power over itself, a form of 1, to give it the same denominator so that we can combine the two terms together. The numerator of the first term we can distribute the x in, giving it x squared plus 2x. The numerator of the second term will be minus those two expressions multiplying each other. Since they have the same base, we can add the exponents. 1/2 plus 1/2 is 2/2 or 1, so it'll be x squared minus 16 to the first power, and there's a minus sign in front of it, so we will keep it in parentheses because the minus sign will need to distribute in there. All of that over their common denominator. And then the overall denominator. In the numerator, we have an x squared plus 2x. We can now distribute the minus sign here to give a negative x squared and a positive 16. And then 1/2 power can be rewritten as square root, so that'll be square root of x squared minus 16. In the numerator, we can combine like terms, and the x squared and negative x squared will cancel each other out. At this point, we can, since we have a fraction in the numerator, reciprocate the denominator fraction and multiply it with the numerator. It's not a fraction in the denominator just yet, but we can put it over 1 to make it a fraction. It can now reciprocate and multiply. So we have 2x plus 16 over the square root of x squared minus 16, and it'll be multiplied by 1 over x plus 2 squared. The reciprocal of the denominator. So we can now multiply the numerators together. Anything times 1 is itself, which will give 2x plus 16. And multiply the denominators. So I'll have the square root of x squared minus 16 as well as x plus 2 squared. We have the derivative written as a single fraction All of the powers are positive. At this point, we can set the numerator equal to 0 and the denominator equal to 0 and solve for each of the x's. Starting with the numerator, 2x plus 16 equals 0. Subtracting 16 from both sides, 2x equals to negative 16. Divide both sides by 2, x equals negative 8. Now working with the denominator, square root of x squared minus 16 times x plus 2 squared equals 0. We can work with each of these separately since they're multiplying each other and equal to 0. They each can be set equal to 0. Working with the square root first, we can square both sides. Square root squared cancel each other out. 0 squared is 0. The difference of squares factors into x plus 4 and x minus 4, which means that x can equal negative 4 or x can equal positive 4. And now working with the x plus 2 squared, the first thing to do is take the square root of both sides. The square root of squared cancel each other out, and x plus 2 equals 0. And this gives, by subtracting 2 from both sides, x equals negative 2. We will now check to see which of these will be in the domain. The domain is negative infinity to negative 4 included, and then positive 4 to positive infinity. Negative 8 is in that domain because it is less than the negative 4, so it's in the first portion of the domain. X equals negative 4 and x equals positive 4 are both in that domain because they are the endpoints that are included in each of the pieces of the domain. X equals negative 2 is not within the domain because it sits between negative 4 and 4, and that piece is not included in the domain. So we can cross this one out. And there are the three critical numbers for the function: x equals negative 8, x equals negative 4, and x equals positive 4.